Assalamu alaikum, our honorable faculties. Welcome to our lab presentation of CSE 461 Introduction to Robotics. We are group 16 and Isme Mehdi bin Sarwar Soron. Now we are going to build a line follower robot in Webots, and I am going to describe it from the beginning. So first of all, we need to create a new world from wizards by selecting the new project directory. Secondly, we need to create background and we need to add lights. So at first we need to click the add button from the menu bar, and it may take some time. Then through the protonodes and the objects we have added our texture background. Next we have added the background lights in the similar way. After that we had to create floor and walls. In order to create floor, we have introduced the rectangular arena from the protonodes and made the floor solid as well. Additionally, we have taken four walls, named wall 1, 2, 3, 4, and adjusted their size and position. As our task was to make a line follower robot, that's why we have added some objects so that our environment seems more realistic. For making this from the objects through the protonodes, we have added few objects like tree, brains, dustbin, and water bottle. Now, apart from this, we input the line for the truck. So for doing this, we have to go to the Autodesk Tinkercad, then by selecting create a new design. After that, by the Scrabble, we have drawn the line. Next, we make the height of this line very low, and for more visibility, we colored it black. And now our path is ready. So then we export it by the obj file. As I have already done it, so I am not going to do this again. Now we have to implement this line into the Webots. For doing this, we have to go to the file and select the import 3D models, and we have to select the recent downloaded path. Finally, we have placed it in the floor so that our robot can go forward by following this line. So here my part is done. Now my friend Rashik will describe his part.
Assalamu alaikum everyone. My name is Rashik Almois from Group 16. So previously my friend Soron has already described about the surroundings of this project, the oak tree, the bench, the basket. So now I'm going to talk about the robot that has been implemented here in our line for our robot project. So at first, to select the robot, we know that we have to select the plus sign. From the plus sign we can select the base nodes, and then we can select the robot, and then we can add it in our project. But as I've already done it once, I'm not going to do it the second time. So if we go inside the robot, we can see that there is a section called children. So we select on children, and then we can see that we have given the robot a definite body shape, and inside the body shape we can see that we have given the robot a definite appearance and also a geometry box. So if we click on the appearance, we can see that the color that we have given to the robot is the color of our robot is red, green, and blue, and we have also mentioned the ratios in which the colors are put into. Also, if we select at the geometry box, we can see the sizes of XYZ are also determined as 0.1, 0.05, and zero point 0.2. So we have given the robot a definite size, and we have given it a definite physics. In order to make the wheels of the robot, we have also uh, applied hinge joint. So for the four wheels of the robot, we have copy and pasted the hinge joint 3 times. So this is how the robot has been built. So now if we run the simulation and see what the robot can do, so to view it better, we will go to the full screen, and then we can run the simulation. So as you can see, the robot has already done its simulation, and also we can see that the robot is moving exactly along the line and is not moving elsewhere. The robot is doing what it is supposed to do. It is moving just along the line. And also we can see here that the simulation is running successfully. So we pause the simulation, and so this is how we can say that the robot has been built, and the rest of the part will be described by Kanon, the code that we have implemented here for our line follow robot project. So this is all from me. Thank you so much.
Hello, assalamu alaikum. My name is Kamal Kanon and I am from Group 16. As my group member Rashik already talked about working mechanism of the robot, now I am going to talk about the code that has been implemented in our project. At first, from the wizard, we added a robot controller by using Python language. Then we assigned the line follower robot. At the very beginning of the code, we selected the time step 32 and also selected the maximum speed of the robot 6.28. After that, we have implemented the wheels for front and also for back wheel. After that, we go through the go through the values of the sensor. From this part of the code, we get the values for a robot. Here we initiate the sensors for the robot and also the path. This lane should be same as this one. Here we can edit the code over here also over from here. Then came to the process sensor data. Each condition, if we try to maintain the paths after playing the simulator, we saw it is not following the line. Then we calculate it. After calculating the sensor data, we found that when the middle sensor is on the line, it gives us the value 900. If the sensor is not on the line, then we get less than 900 values. If any of the sensor is on the line, it gives more than 900 values. If we run the simulator now, it's following the line perfectly. So we are getting the robot running on the path perfectly. So for the calibration part, we need to check the values very carefully, otherwise it will not follow the path. Thank you everyone.